So yesterday we talked about arithmetic sequences. Today we're talking geometric sequences. It's when you are multiplying the same number as you go down the line. So yesterday it was called the common difference, the number you were adding each time. Today the number you're multiplying each time is called the common ratio. So determine whether each sequence could be geometric or arithmetic or neither. If possible, find the common ratio or difference. So if I'm looking at A, first thing I would check is arithmetic. Are we adding the same number? So like 8 to 12 is up 4, but 12 to 18 is 6. So arithmetic is out. Geometric, maybe. Are we multiplying the same? I don't know 8 times what gives me 12, but just like yesterday, if you're seeing what the common difference is, you could do the second term minus the first term. Here we could do the second term divided by the first term. So you could always divide by the term right before it. So we could check 12 divided by 8. We could check 18 divided by 12. We could even check 27 divided by 18. These all would need to come out to the same number for it to be a geometric sequence. And it does. It comes out to 1.5 for each of them. So it is a geometric sequence. The common ratio, that's a weird R, is that number we're multiplying. It's the 1.5. That's all it's asking for. If you wanted to find the next number, 27 times 1.5 equals times 1.5 equals time. You could keep doing that. Look at B. 8 to 16, you're like, times 2, I'm on a roll. 16 times 2, 20. Oh. So we're not multiplying by the same amount, but are we adding the same amount? I don't know. 8 plus 8 is 16, plus 8 is, oh yeah, so we are adding each time. Adding arithmetic, and our common difference here, we are adding 8 as we go down the line. All right, this last one, 6 to 10 is 4, 10 to 15 is 5, so arithmetic out. Let's check geometric. 10 divided by 6, 15 divided by 10, 21 divided by 15. These would all have to work out to the same number. So this would be like 1.6 repeating. 15 divided by 10 is 1.5. It's already different. Who cares what 21 divided by 15 is? It's not the same. So this would be neither. So there might be a pattern, but it's not a geometric or arithmetic sequence. So we're done. All right, you look here. Whoa, fractions. Wow. Are we adding the same amount? I don't know, but we could check. We could do a term minus the term before it. 1/12 minus 1/4. We'd have to get that common denominator, which could be 12s. So 1/12 minus 3/12 is negative 2/12. Or negative 1/6. We'd have to check that with another one. So if I did 1/36 minus 1/12, get that common denominator, 1/12 would be 3 over 36. That would give us negative 2 over 36, which is negative 1/18. So arithmetic out. We got to check geometric. Remember, you do the term divided by the term before it. But if we're doing 1/12 divided by 1/4, ooh, dividing fractions, do the old keep, change, flip. So dividing by 1/4 is the same as multiplying by 4 over 1. This will give us 4 over 12, which is 1/3. Cool, let's check another one. 1/36 divided by 1/12, or times 12 over 1. This will give us 12 over 36, which also happens to be 1/3. OMG. If we did 1/108th divided by 1/36, or times 36 over 1, it gives you 36 over 108, which, believe it or not, is 1/3. So this is another geometric sequence, and our common ratio is 1/3. You could say it's 0.3 repeating if you want to. All right, here we go. Look, there's a pattern here. It's going down by 0.4 each time. That's an arithmetic sequence. and our common difference is that negative 0.04. Well, these were both geometric. These were both arithmetic. I wonder what this one's gonna be. All right, well, let's see, this is going up 18. And that's going up 14. This is going up 10. Okay, it's not arithmetic. We could check, geometric. Negative 32 divided by the term before it. This will give you positive 0.64. If we check another one, let's see, negative 18 divided by the term before it. I don't know what that is. 18 divided by 32. 0.5625. Not the same. As soon as you see they're dividing differently or they're subtracting differently, it's not going to work. So this one is also neither. All right. That was fun. Almost as fun as this. Look, here's the new formula for a geometric sequence. A sub n, general just function notation for these sequences. The a sub 1 is always the first term, and then it's the times the common ratio, and the exponent on the common ratio is n minus 1, the term number minus 1. So let's set up that general formula for each one, and then we'll find the term that they want. So here, if we're setting up the general, a sub n equals our first term, negative 5, times the common difference to the n minus 1. Now, what are we multiplying by as we go down the line here? 5 to 10 normally is times 2. 10 times 2 is 20. But I see that it's alternating as well. It's going positive times negative to, positive to negative. So we're multiplying by negative 2 as we go down the line. That's our common difference here. There's our general setup. And then it says to find the 9th term. A of 9 equals negative 5 times negative 2 to the 9 minus 1. Now, 9 minus 1 is 8. When you have a negative number to an even exponent, it's going to work out positive. Let's see what 2 to the 8th is. 256. And then the last thing you're going to do is multiply it by the negative 5, which switches it to negative 1280. All right, so let's set this one up. A sub n, our first term is 0.001 times the common ratio to the n minus 1. Now, we can look anywhere in this pattern. I would look over here, 0.1 to regular 1 to 10. Now, 1 to 10, you're multiplying by 10, right? So as we go down the line, we are multiplying by 10. That's our common ratio here. And then it says, what would the 9th term be? A sub 9 equals 0.001 times 10 to the 9 minus 1. All right. 0.001, 10 to the 8th. I can't even write numbers. That's how excited I am. 10 to the 8th is going to have 8 zeros total. 1, 2, 3, 4, 5, 6, 7, 8. 100 million. And 100 million. Mine doesn't have things in there. I think that's 100 million. 3, 6. All right. Times 0.001. 100,000. 3, 1, 2, 3. Yeah, that makes sense. All right, last one. Our first term is 3. A sub n equals 3 times the common ratio to the n minus 1. Now, look down the line there. 3 to 12, you're multiplying by 4. Is 12 times 4 48? Yeah. Is 48 times 4 192? You bet. So there's our general formula. Now we're going to find the 9th term. A sub 9, 3 times 4 to the 9 minus 1. 9 minus 1, we're not silly, is 8. 4 to the 8th, no idea what that is though. 65,536 times 3. 196,608. Whoo-wee! That was brutal, but we're done with the geometric sequences, and we're having fun.